Hello, let's continue our Sudoku adventure with In-Group by ChinStrap. So we have irregular 6x6 Sudoku rules. That means in each row, each column, in each of these bold outlined regions, we are placing the digits 1 to 6 exactly once each. So we don't have our normal 2x3 boxes. Instead, just look at where the bold borders are. There will be 6 cells surrounded by bold borders, and those 6 cells have 1 to 6 exactly once each. We also have a minimum cell here and 5 maximum cells. The way the minimum cell works is it has to be smaller than all of the digits surrounding it. So if this was a 3, for example, then all of these have to be bigger than 3. So we can't put like a 2 here because that breaks our inequality. Notice this says 2 is greater than 3, and that's no good. This has to be smaller than all 3 of these, and it isn't in this case. So I could do, say, 4, 5, 6, and then another 4 there maybe. This would be fine, but if this was a 2, that would not be fine. All right, and these are the opposite. These need to be larger than all the ones around it. So if this was a 3, for example, then I could do 1, 1, 1, 2, 2, 1. That would be one way to do that. Because all of these are now smaller than this. This is the largest of this grouping. It has to be exact. It has to be the largest one. So what I can't do is put a 4 here because that would break this inequality here. All right, and no, that's not it. In addition to that, our minimum and maximum cells form an additional extra region. So we're placing 1 to 6 exactly once each within our min-max cells, these 6 cells here. And that is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. First thing I noticed is we needed this one minimum cell because we need to put a 1 in one of them. You can't put a 1 in a maximum cell, no matter where it is, because there's nothing you can put next to it that is less than 1. It has to be the biggest of its group, and 1 just does not work that way. 1 is the smallest digit already. And so this is the only one that can be 1, because it needs to be smaller than all the ones around it. So I guess it means these are from 2 to 6. But we should probably think about 2 next, because 2 is quite limited. Anywhere where it's surrounded by cells in the same row or column can't be 2 because they can't both be 1s. 1 is the only digit smaller than 2. In order for this to be the biggest of these, we need to put a 1 in all of these, and that's obviously bad. And so the only one I see on the grid that works for is here. This can be a 2 because these can both be 1s. It doesn't have a row or a column surrounding it. But this has this row, this has this column, this has this row, this has this column. So, sorry, this is our 2, and it's surrounded by 1s. Can I do more with, I have 3 1s placed. Can I do more with them? You'd think I could. Scanning irregulars can be a little difficult. All right, well, we did place a 1 in this region, so let's just move on. 1 in this region means that these are at least 2. So you'll notice this cell here has to be bigger than all 4 of these. And these 3, in fact, all 4 of them can't be 1. But these 3 all have to be different because they're part of the same region. And so the minimum I could put here is 2, 3, 4, which does force this to see a 4. And so this sees at least a 4, making it a 5 or a 6 only. This could see a 2, 3. We could have a 2 here and a 3. In fact, this is a 2. This 2 looks in here. This region needs a 2. So this is a 2. But it needs to, this could be as low as 3. And so this could be 4, 5, or 6. This one here, let's see. I'm thinking whether either of these can't be 3. I'm seeing if 3 is placeable. So if this was a 3, it would need to be surrounded by 1s and 2s. Okay, so the issue is this cell here actually can't be 1 or 2. It's from 3, 4, 5. You can't put a 6 next to a maximum cell because then the maximum cell can't be bigger than it. So, and then this can't be 1 or 2. So this is from 3, 4, 5. And so both of these, neither of these can be a 3, right? I guess this can't be a 3 is the important deduction. It's from 4, 5, 6 because this is minimum 3. It needs to be smaller than it. If I tried to put a 3 here, this would be bigger than it for sure. And so that actually places the 3 here, which is surrounded by 1s and 2s. This can't be a 1, so that's a 2, making that a 1, and this shares a region, making that a 1. That leaves 4, 5, 6. This region here needs 4, 5, and 6. It has 1, 2, and 3. So this here, this can't be the 6, and this can't be the 4, because this is strictly bigger than this. Making a 5, 6 pair in my extra region, forcing this to be 4 and that to be 3. All right, that's not 4. This is a 5, 6 pair to finish this region or row, or this row. This is a 4, 5, 6. Okay. What do we do next? Should we look at... This is a 5, 6 pair. So this cell here cannot be 5. This cell here can't be 5. Okay, it can't be 5. It sees a 5, 6 pair. And so 5 is not going to be smaller than whichever one of these two ends up 5. The reason it's a pair is because of our extra region, right? Otherwise it wouldn't be necessarily a pair, but it has to be because of the extra region here, 1 through 6. So this is a 3. So I need a 5 somewhere. It's not here. So this is 2 or 4. Try to be careful here. What do we need in this column? We do need a 1 in this column, and we need the other 5, 6. Hold on. How am I doing on... Oh, I can actually just place... Sorry, 1 in this column goes here. This isn't... These aren't 1. Well, this is the last one in the grid. It goes here. So this is 5, 6. We put a 5, 6 pair across an inequality. This is the smaller one. So this is 5. This is 6, making that a 5. Okay. So now 6... oh, yeah. 6 in this box goes here. I could have realized that. There's a few things I could have realized, but I'm doing okay. That's not 6. This is 5 and 6. 4, 5 pair. Let me deal with that in a second. This is 2, 4, just to finish this region. And so these need to be 3 and 6. All right, what I was seeing here is this 4, 5 pair. These two cells see both the 4 and the 5. They see it through the row and they see it through the region. So if this was 4, 5, these can't be 4 or 5 because of the row and region. And if this was 5, 4, this still can't be 4, 5. Oopsie. Because of the row and region, right? So however this 4, 5 pair resolves, these are not 4, 5. So they're not 1, 4, or 5, leaving 3. They're not 1, 4, 5, leaving 2, 3, 6. That's not 3, that's not 6. Okay. I suppose we could have said, yeah, there's another deduction we could have gotten the same result for, which is that these 3 cells don't go here, so they go here. So this is 1, 2. We already know where the 1 is, so the 2, 3, 6 go here, 2, 3, 6 here. Oh, and so actually we know that 2 is one of these two. 2 looks in here, it's not here. So yeah, 2 is in one of these two, making this the 4 and this the 2. That makes that 5 and 4. Okay, that's a 4. So what are these down to? 3, 5, 6. The 5 looks up, so that's 5. This is a 3, 6 pair. 6 looks down, that's 3, that's 6. So that's 2 and that's 6. Perfect. This row needs a 3. This is a 3. This column needs a 6, and this 6 has none of those. So that's our 6. This is a pair. Actually, we can finish the rows, but we need a 4 and 5. So that's 4, that's 5. And then here we need 2 and 4. That's 2, that's 4. All right, neat puzzle, ChinStrap. We really made good use of the extra region in the min-max. That was pretty neat. I was thinking we were going to have a lot of irregular logic when I got started because of the shape of the regions, but it ended up being this extra region here with the min-maxes that did a lot of the heavy lifting. So very focused puzzle. Neat idea as well. Let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.